Honors Algebra 1, Mid-Chapter 7 Test, Answer Key. Problem number 1. N cubed and n squared have the same base, so we add their exponents. 3 plus 2 is 5. R and R, same base, add their exponents, r to the 9th. Okay, number 2, we have to distribute the exponent first to both parentheses. 3 squared is 9. Power raised to a power, those exponents get multiplied, so that's w to the 4th. And then r to the first squared is r squared. Okay. Negative 2 cubed, negative 2 times negative 2 times negative 2 is negative 8. Again, a base with an exponent raised to a power. 5 times 3 is w to the 15th. R to the 2 times 3 is 6. Okay, so here we've just got a parenthesis times a parenthesis. Numbers get multiplied. 8 times 9 is negative 8 times 9 is negative 72. W's have their exponents added, multiplication. R's have their exponents added, r to the 8th. Okay. Number 3, this is our power to a power rule. So this, got a couple of things happening here all at once. We'll focus on the inside parenthesis first and leave our bracket raised to a power alone. So inside that bracket we have negative 2 cubed, which is negative 8. X squared raised to the 3rd power. Again, that's multiplying exponents. So that's 2 times 3. Y, same thing, to the 1st cubed. 1 times 3 is 3. Z to the 9th. And then we get to do that again because we still have all of that is inside the bracket, which is being raised to the power. So we've got negative 8 cubed. So that's, what is that, 64 times 8. Okay, so that's going to be negative 512. And then x to the 6th cubed is going to be x to the 18th. And y to the 9th. And z to the 27th. Okay. Get to number 4, we start dealing with the division properties, the quotient properties. So m's on top of m's, we subtract exponents. So we have m, 6 minus 2 is 4. And then we have n. Now 3 minus 6 gives us n to the negative cubed, but we've already talked about negative exponents. They can't stay where they are. They want to go somewhere else. So this n to the negative 3 is in the numerator, so we're going to have to move it to the denominator. And now it's a positive 3, into the positive 3. All right, number 5. Number 5, we're going to have to, let's distribute those exponents first using our power to a power rule. So we've got z to the 6th, w to the negative 3, and on bottom we have another z to the 6th and a w to the 4th. Okay, so using our quotient rules, z, 6 minus 6 is going to be 0. So in just a minute we'll remind you of that 0 exponent rule that says that's going to be a 1. And then we also have minus 3 minus 4, which gives us w to the negative 7. So that can't stay where it is. It's got to move. So z to the 0 is just 1. W to the negative 7 has to move to the denominator. All right. Number 6. 2x cubed, y to the 5th on top. Like, we don't do anything with that yet because there is in the denominator a power to a power that we've got to take care of. Now this 5 is outside the parentheses, so nothing happens to it. X to the 4 times 3 is going to be 12th power. Y to the 2 times 3 is going to be the 6th power. All right, now we can simplify. Okay, so we're going to have this fraction over here because the 2 and the 5, those are numbers. That's just a fraction. And so 2/5, if it would reduce, we would. It won't, so we won't. Okay, x cubed on top, x to the 12th on bottom. So 3 minus 12 is -9. That's on top. So it has to go on the bottom as a +9. 5 minus 6 would give us y to the -1, which again is on top. So it has to move to the bottom as a y to the first. Okay. Number 7, no power to a power to deal with. But looking at our -10 over -14, that's a part of our fraction that would reduce. 10 over 14, -10 over -14 is going to reduce to 5/7, right? 2 in common would cancel out. All right, so let's look at the m's. We've got -1 and then a -7 on the bottom. So -1 minus a -7. So that's going to give us m to the 6th. And that's on top, and that's happy just right where it is. Okay. We've got y to the 0 and y to the -3. So 0 minus a -3 is going to give us a y cubed on top. And then we also have r to the first and r -4 on bottom. So 1 minus a -4 would also give us a 5 on top, r to the 5th on top. Okay, I'm going to clean it up just a little bit. I don't like my numbers to be hanging out too far. But there it is, 5m to the 6th, y cubed, r to the 5th, all over 7. Okay, number 8, scientific notation. So scientific notation tells me that I can only have one non-zero digit to the left of my decimal. So my answer is going to need a decimal right there to the right of the 7 with a 0 and 2 there. It's going to be times 10 to some power. How far did we move our decimal? 1, 2, 3, 4 places. And then what we've said is that decimals are going to give us negative exponents. Okay, so 7.02 times 10 to the -4th. Now there are rules. You can read those rules that talk about moving it left and right. The easier way to remember it seems to be decimals line up with, those small numbers give us negative exponents and larger numbers give us positive exponents. We'll see that again as we get to the back page here. So we get to do here, we talked about grouping the numbers and then just handling the exponents as we get to them. So on number 9 here, we get to do 4.5 times 1.6, and we get 7.2. Now that's already in scientific notation, so we're just going to leave 7.2 times 10. And if I look at our exponents, 10 is the base with both of them. Add those exponents. 9 minus 5 is 4. And so we'd have 10 to the 4th. Okay. Number 10. Again, we get to multiply our numbers. And 7.2 times 4 gives us 28.8. Now that's not scientific notation yet. To put this number in scientific notation, it would be 2.88. Right, one non-zero digit to the left of the decimal. Now this is compared to a decimal, this is a large number, right? So that would give us a positive exponent, and we move that decimal place one time, so it would give us a +1 for the 2.88 to be in scientific notation. Now let's see what our times 10 to the powers give us, right? Same base, so we add those exponents. -7 -3 -4 would give us a -7. And so now we've got 2.88 times 10, and we combine those exponents again. We add those exponents, and we end up with a -6. Okay. Number 11, again, let's handle our numbers. We just do that division. 6.4 divided by 12.8 is going to give us 0.5. Not in scientific notation. We've got to move that decimal one place. Okay, so there's our decimal. We've moved it one place. And then this was a decimal number, right? This was a small number, so it gives us a negative exponent. So moved it one place, negative exponent, so that's going to be a -1 times 10. So same base, 7 minus a -2, going back to our quotient rules of exponents. 7 minus a -2 would be 9. And then when we combine those two exponents, we have 5 times 10 to the 8th. All right. 12, 13, 14. We've got to get our base has to be the same before we can solve these equations. Okay, so I have a 5 on the right-hand side of the equal sign. So I really, if I could use 5, I'd like to use 5 for the left-hand side of my equation. And so 125 is 5 cubed. All that is still being raised to the x power. So product power of a power rule says that 3 and the x are going to be multiplied. That 3 and the x, now that our bases are the same, 3x is going to equal 1. And then this is an equation we can solve. So x would equal 1/3. Okay. Number 13, again, we've got to get the same base. If we try to use 9 as a base to get to 243, that one doesn't work. But we think 3 probably will, right? Looking at 9, that would be our other choice because it can be written as 3 squared. Okay. So let's see if 3 can be used as a base for 243. And it can. 3 to the 5th. So let's go back and use our power to a power rule again. And that 2 is going to be multiplied times 3x minus 1. And it's going to equal 5. So we got the bases the same. And so then our exponents become the equation that we can solve. Distribution. Solving of the equation. And x equals 7/6. Okay. Now some of you wrote 1 1/6. That's perfectly fine. Exponents, you know, they're fractions if they're going to be rational. But for the sake of finding an x value, 1 1/6 would have been just fine. All right. So 14, again, we're trying to get the same base. And so in getting the same base, it doesn't look like 8 would work. But we've played with this enough. Now that we know that 8 can also be written as 2 cubed. Okay, so it's going to be 2 cubed raised to the x power. 16 is 2 to the 4th. Bases are the same. So the exponents give us the equation. 3 times x equals 4. So x equals 4/3. Okay. 15. Again, trying to get the same base. We're going to try to see if 36 will work. It will not, but it does look like 36 could be rewritten as 6 squared, and 216 would be 6 cubed. And that's just us playing with numbers to figure out what's going to work. Okay, so bases are the same. Exponents are the equation now. So 3 times the x plus 1 equals 2. Distribution. And then solve the equation. And x would equal -1/3. Okay. Now I want to go ahead and work the bonus. It's been a while since we've done one of these. We were given a point and we were given a slope. And so hopefully you remember point slope form. Y minus y1 equals m x minus x1. And then we have the x1, y1 to plug in. And we have the slope to plug in. And so here we go. Y minus a minus 1 equals 5 halves x minus 4. And from here, it's just distribution and getting y by itself again. We wanted it to be in slope-intercept form, which is y equals mx plus b. So here we go. Y plus 1 equals 5 halves x minus 10. Subtracting 1 from both sides, we would get 5 halves x minus 11. And then this was our equation. Okay.